So you've probably heard of the jet streams before, and there are actually two jet streams in each hemisphere. Now if I go down here to this globe over here on the left and I put an H for Hadley, an F for Ferrel, and a P for polar, H, F, P, you can actually see kind of these ribbons of kind of encircle the Earth. Now, the jet streams are basically just fast ribbons of fast-moving air, where we have these kind of clashing cells where these cells meet. Now, the ribbons aren't necessarily complete. So, for instance, I know it's an interesting thing if you have a hot air balloon, for instance, who is trying to kind of make its way across the world, and you have the jet stream kind of fragmented. It definitely does that sometimes. The top one is called the subtropical, wait, not the top one. This one right here is called the subtropical jet. So there we have two subtropical jets. The subtropical jet is, of course, then between the Hadley and the Ferrel cell. And the polar jet then is between the Ferrel and the polar cell. So we have two. Okay, and actually these jet streams can be players for moving air and moving weather patterns, or not moving weather patterns, to create our day-to-day weather. So here I have, it looks kind of complicated, but if we look at it, you can see the 0 over here on the side, the 0, the 30, the 60, kind of orient yourself to Hadley, Ferrel, and kind of polar cell. Then we have things that we already talked about. So for instance, here in red, I'm going to say here in the Hadley we have the northeast trade winds. Here in the Ferrel we have the westerlies, actually mid-latitude westerlies or westerlies. Here in the polar cell we have the polar easterlies. We also then have these created regions of kind of semi-permanent high and low pressures. Not so surprising, near the intertropical convergence zone, we have a low pressure at the surface because of that rising air. Here, where we said kind of maybe we have deserts, here about 30 degrees, we have a semi-permanent high. Here between for this rising air, between the Ferrel and the polar cell, we have a semi-permanent low. And here, up here at the poles, we have a semi-permanent high. Okay, oops, I bet I could have gone ahead and put all that up. Okay, so we end up with those kind of semi-permanent highs and lows, which actually have consequences for kind of our prevailing winds. So semi-permanent highs around here, okay, and then our semi-permanent lows, okay, we have actually here and here. Okay, cool. And a semi-permanent high up here.